3I Atlas is one of the most extraordinary cosmic visitors humanity has ever seen. It is not just another comet. It came from outside our solar system, from a distant star system light-years away, and it is the third interstellar object ever confirmed to pass through our cosmic neighborhood. That alone makes it rare, but what we are learning from it is even more astounding. The discoveries so far suggest that 3I Atlas could contain chemical clues that help us understand the very building blocks of life, long before our own solar system existed. The object was first spotted on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a global survey telescope system designed to catch incoming asteroids that could threaten Earth. ATLAS was monitoring the sky when it detected a fast-moving object on a trajectory unlike anything normally seen. Scientists quickly determined that the object was on a hyperbolic path, meaning it was moving too fast to be bound by the Sun's gravity. Instead of orbiting the Sun like a normal comet or asteroid, it was on a one-way journey through our solar system, passing close and then continuing onward into deep space without ever returning. This is the classic signature of an interstellar object passing through the solar system, and so it was designated 3I Atlas, where 3I means the third interstellar visitor confirmed after 1I Oumuamua in 2017 and 2I Borisov in 2019. From the moment it was discovered, astronomers around the world pointed their telescopes at it. What they saw was unlike most comets from our own solar system, and soon it became clear that 3I Atlas was scientifically invaluable. By late October 2025, the comet made its closest approach to the Sun, passing just inside the orbit of Mars at about 1.4 astronomical units, or roughly 210 million kilometers from the Sun. It did not pose any danger to Earth, staying far beyond the reach of our planet at all times. Its speed and hyperbolic orbit confirmed without doubt that it originated outside the solar system. As with any comet, 3I Atlas began to heat up as it neared the Sun. Ices on its surface, frozen water, carbon dioxide, and other volatile compounds, sublimated directly into gas, forming a fuzzy atmosphere called a coma, and often a tail that streams away from the Sun. But 3I Atlas has already surprised astronomers in how it behaves. Observations from the James Webb Space Telescope revealed that its coma is dominated by carbon dioxide gas, at levels far higher than is typically seen in comets from the solar system. Carbon dioxide appears to be the major driver of activity in this object's coma, with water and carbon monoxide also present, but in comparatively lower quantities. These unusual chemical ratios suggest that 3I Atlas may have formed in a very different environment, perhaps near the carbon dioxide ice line of its original star system's protoplanetary disk, or in a region of space exposed to intense cosmic radiation that altered its chemistry over billions of years. Most of all, what has captured scientists' attention is that this comet may be carrying ingredients linked to the chemistry of life. Recent studies using arrays such as the Atacama Large Submillimeter Array have detected surprisingly large amounts of methanol, a simple alcohol molecule, and hydrogen cyanide streaming from the nucleus and throughout the coma. Methanol is of particular interest because in astrochemistry it is considered a basic building block in pathways that lead toward more complex organic molecules. On Earth, methanol can contribute to reactions that produce amino acids, proteins, and even the precursors of DNA and RNA under the right conditions. Hydrogen cyanide, though toxic to life as we know it, is also a molecule that appears in many laboratory simulations of prebiotic chemistry. The relative abundance of these molecules in 3I Atlas is striking compared to the usual trace amounts seen in comets from our own solar system, suggesting that the processes that formed and altered this object were very different and potentially rich in life-friendly chemistry. In addition to these chemical clues, 3I Atlas shows physical behaviors that continue to intrigue researchers. The Hubble Space Telescope captured high-resolution images that reveal a complex coma and tail structure, with multiple streamers and jets of dust and gas. The object's appearance, its color shifts, and the way its emissions change over time indicate that it is dynamically active in ways that challenge simple comet models. Observations suggest that it releases hundreds of kilograms of material per second at times, and that this release happens even when the object is still far from the Sun, where ice sublimation should be minimal. These patterns suggest that there may be processes at work on 3I Atlas that are not fully understood, potentially involving deeper layers of volatile ices or complex reactions within its nucleus. Some scientists have even pointed to the presence of metals or metal-rich emissions in the object's coma. Early spectroscopy indicates that nickel and cyanogen may be present in significant quantities, indicating a mix of elements that is unusual for comets. In some preliminary data, astronomers have reported that nickel emission appears more centrally concentrated than other gases, possibly hinting at internal processes or materials that are uncommon among typical cometary nuclei. While these findings are still under study and debated, they add to the sense that 3I Atlas is telling us something new about the variety of materials that can form around stars other than our own. The presence of these complex chemicals tied to prebiotic pathways raises exciting questions about the distribution of building blocks for life across the galaxy. If comets forming in other star systems carry similar molecules, then the seeds of life, or at least the raw ingredients, may be widespread. This supports the idea that the raw chemistry necessary for life could be common in the universe, carried on icy bodies that drift between stars and deposit their material when they enter new systems. In this sense, 3I Atlas acts as a messenger from another world, carrying with it a chemical library that may help scientists understand how life-friendly chemistry can arise in environments very different from our own. Not every scientist agrees on interpretations, and the notion that 3I Atlas might carry traces pointing to life's chemistry does not mean it contains life or is evidence of extraterrestrial organisms. Instead, researchers emphasize that it contains molecules that on Earth play roles in prebiotic chemistry, the set of chemical reactions that could, under the right conditions, lead to the formation of the first organic compounds necessary for life. These findings expand our understanding of how diverse chemical compositions can be in different parts of the galaxy, and how conditions for life's chemistry might arise in environments far removed from our own. At the same time, the object's origin and age remain subjects of active research. Based on its trajectory and speed, astronomers estimate that 3I Atlas may be an ancient object, possibly over 7 billion years old, older than our own solar system. If this is correct, it formed in a stellar environment that existed long before the Sun was born, perhaps in a region of the Milky Way's thick disk where older stars congregate. This means we might be seeing material that predates the formation of Earth and carries clues about the early history of the galaxy itself. While NASA and other space agencies maintain that the data so far support a natural cometary explanation for 3I Atlas, the fact that it behaves differently from typical solar system comets keeps the scientific community deeply engaged. Some scientists, such as Harvard astrophysicist Avi Loeb, have argued that unexplained aspects of its motion and composition deserve open consideration of alternative hypotheses, though mainstream scientists emphasize natural explanations such as the comet's unique formation environment. 3I Atlas poses no danger to Earth. Its closest approach to our planet will be at least 1.8 astronomical units, or about 270 million kilometers away, far beyond the orbit of Mars. This distance ensures that, while scientists can observe it closely with telescopes from Earth and space, it will not impact our world or pose any physical threat. The real importance of this object lies not in danger, but in opportunity, the unique chance to study material from another solar system up close. Scientists around the globe continue to monitor 3I Atlas using a range of observatories and instruments, from Hubble and ground-based telescopes to long-range surveys. Observations are scheduled to continue as the object moves away from the Sun and back into interstellar space. Each new finding adds pieces to a complex puzzle. Through careful analysis of the gases, particles, and behaviors of 3I Atlas, researchers hope to unlock deeper insights into how planetary systems form, how organic chemistry evolves on icy bodies, and how the galaxy distributes the molecules that might one day give rise to life. The story of 3I Atlas is still unfolding, and every new observation adds richness to our understanding of the universe. This small, icy visitor from a distant star system has already rewritten part of the story of interstellar objects, and it may yet tell us more about how life's chemical precursors are scattered among the stars.